We are doing grade 11 NCRT exercise for the topic Some Basic Concepts of Chemistry, and today we'll be doing question 1.25 to 1.29. For the previous question on the same topic, you can watch my other videos. So the very first question, how are 0.50 mole sodium carbonate and 0.50 molar sodium carbonate different? So they have given you two information. First is 0.50 mole sodium carbonate, that means amount or mass of substance is given to you, and 0.50 molar sodium carbonate means they have given you a solution of sodium carbonate where molarity of the solution is 0.50 m. So for the questions related to number of moles and the concentration, we have to very first find out the molar mass of the substance given to you with the help of atomic masses. So molar mass of sodium carbonate is calculated as 106 grams per mole. We know that number of moles is calculated as mass divided by molar mass. So mass of substance we can calculate by multiplying number of moles with molar mass. So they have given you 0.50 moles sodium carbonate. So this number of moles, when we multiply with the molar mass, you will get the mass of sodium carbonate. So this is the mass of substance which is given to you. That is, you have here 53 grams of sodium carbonate solid. Now molarity, we know that we calculate as number of moles divided by volume of solution. So here 0.050 molar sodium carbonate means 0.50 moles of sodium carbonate is dissolved in 1 liter of solution. Now here we have seen that 0.50 moles sodium carbonate is basically 53 grams of sodium carbonate. So therefore 53 grams of sodium carbonate is dissolved here in 1 liter of solution to give you a solution with a concentration 0.5 m. So in the first information, they have given you amount of substance, that is solid compound or the solute. In the second one, they have given you a concentration of the solution. Next question. If 10 volumes of dihydrogen gas reacts with 5 volumes of dioxygen gas, how many volumes of water vapors could be produced? So here we have 2 volumes of dihydrogen gas, that is H2 molecule, and 1 volume of oxygen gas, that is O2 molecule, to give you 2 volumes of water, that is H2O. So according to the stoichiometry, when we write down the balanced chemical equation, this is the balanced chemical equation, that is 2 moles of H2 combines with 1 mole of O2 to give you 2 moles of water. We can answer this question directly, but we need to specify that why we are giving or calculating in that way. So here we will apply Avogadro's law, that is equal volume of gases at the same temperature and pressure should contain equal number of molecules. So here ratio of moles is basically equal to the ratio of volume according to the law. So therefore 2 volumes of gases when combined with 2 volumes of hydrogen when combines with 1 volume of oxygen, you get 2 volumes of water. So 10 volumes of hydrogen when combines with 5 volumes of oxygen, you will get 10 volumes of water. So this is the answer. Now next question. It is given, convert the following in basic unit. Basic unit means mass is to be given in kilogram, length in meter, and time in second. So in the very first part, they have given you 28.7 picometer of length. And we know that 1 picometer is equal to 10 raised to the power minus 12 meter. Therefore, your 28.7 picometer will be equal to 2.87 into 10 raised to the power minus 11 meters. Now in the second part, they have given you 15.15 microsecond, that is time is given in smaller units. So here 1 microsecond is equal to 10 raised to the power minus 6 second. Therefore your 15.15 microsecond will be equal to 1.515 into 10 raised to the power minus 5 second. Now in the third one, they have given you mass and we have to write down in the standard unit. So your we know that 1 kilogram is equal to 1000 gram and 1 gram is equal to 1000 milligram. So here 1 milligram can be written as 10 raised to the power minus 6 kilograms. So therefore 25365 milligram will be equal to 2.5365 into 10 raised to the power minus 2 kilograms. Now the next question. Which one of the following will have the largest number of atoms? They have given you 1 gram gold, 1 gram sodium, 1 gram lithium, and 1 gram of chlorine gas. And the atomic masses are also given to you. Now, before calculation, 2 points we have to keep in mind, that is, number of moles of any substance we can calculate as mass divided by the molar mass. And 1 mole of any substance is always equal to the Avogadro's number of particle, that is 6.022 into 10 raised to the power 23 particles. These may be atoms, these may molecule, or any thing else that we consider. So for the very first part, they have given you 1 gram of gold. So we will calculate the number of moles as mass, that is 1, divided by molar mass, that is 197, and you will multiply by the Avogadro's number to get number of atoms of gold. So these are the total number of atoms of gold in 1 gram of gold. Similarly, we'll calculate number of atoms of sodium in 1 gram of sodium and number of atoms of lithium in 1 gram of lithium. But in case of chlorine gas, we have molecule, that is, chlorine is basically diatomic molecule. So first we'll calculate the number of moles of molecule, that is chlorine gas molecule. So here mass given to you divided by molar mass of the gas, you will get number of molecules of gas. This we will multiply by 2 to get number of atoms of chlorine. Now, if we compare all these 4 calculations, the largest quantity will be the one which is having the smallest number in the denominator, and therefore this is the one where we have the lithium with the smallest value of molar mass. So answer will be 1 gram of lithium will have the largest number of atoms. Next question. Calculate molarity of a solution of ethanol in water in which mole fraction of ethanol is 0.040. So first information which is given to you is a solution of ethanol in water, and its molarity we have to find out, and the mole fraction they have already given for the same solution. Now we know that mole fraction we can write as number of moles of solute divided by the total number of moles. So here number of moles of ethanol, that is our solute, divided by total number of moles will be equal to the mole fraction value given to you in the question. So suppose this is our first equation, and we know that molarity is equal to number of moles of solute divided by the volume of solution in liters. So here we will do the very first approximation. Here, since we have to find out number of moles of water, therefore we need mass of water. So therefore volume of water is taken approximately equal to the mass of water, which is taken as 1 kilogram, because density of water is 1 kilograms per liter. Now molar mass of water is calculated with the help of atomic masses, so it is 18 grams. Therefore number of moles of water is calculated as mass, that is 1 kilogram or 1000 gram divided by molar mass. So this is the number of moles of water. Now we will put down this value, that number of moles of water, in equation number 1. So this is the equation that we will get. Now we will rearrange this equation to get number of moles of ethanol from this equation, because here only unknown quantity is number of moles of ethanol. So number of moles of ethanol is calculated as 2.31, and second approximation here we will do volume of solution is approximately taken as volume of water, because here we have a very dilute solution. So here molarity is written as number of moles of solute divided by volume of solution. So you will get 2.31 molar solution. So this is all for today. For rest of the question on the same topic, you can watch my future video. This is all for today. I hope this is clear. Thank you.